Howdy, howdy, howdy. We're talking one and two-step equations. So I thought we'd use some Polypad just to visually show what the heck is actually happening when we're trying to solve these one-step equations. So a one-step equation, you're going to have something that looks like this. You're going to have one side left of the equal sign and the right side of the equal sign. And if we're talking equations, think of that word, equations. What's in that word? What's the root part of that word? Well, equal. And that equal sign is absolutely key. And you may be thinking like, well, duh, we've been doing this since kindergarten. And that's fair, but it's important to really think about what an equal sign is telling us. What it's telling us is that everything on this side must be the same as this side. If this side isn't the same as that, we can't say that they equal. We would say that they do not equal each other. And again, knowing that this side is exactly the same as the other side, okay, that's what that equal sign is telling us. Okay, that's the truth. Left is equal to the right. And a balance beam is a really great way to visualize this. So essentially what we have to do with a one-step equation is we have to solve for the variable. And in this case, m is our variable. The letter doesn't matter. It could be z, it could be t, it could be whatever, it doesn't matter. But m is the variable for now. So we have to figure out what the heck fits in there. Now, you might already know the answer just by looking at that, and that is awesome. But some of these one-step equations use harder terms, and you can't just get it. You can't just see it. So let's understand what the heck is happening visually. So I'm going to worry about the right side of the equal sign right now. Okay, so I have 7 on this side, so let's put 7 of these orange guys there. Why not? Trying to go fast. I know it's kind of tedious watching a teacher monkey around with a computer. Anyhow, okay, so we have 7 on our balance scale. And now notice our scale, it's no longer balanced. This side is heavier, so it's weighed down. And currently, if this is all I had in my scale, I couldn't say that they equal because it's not balanced. I have to have my scale balanced if I'm allowed to use this equal sign. So let's go to the left side. What do I know that I have? Well, I know what 3 is. 3 is 3. So I can put 3 down. Cool. Uh-oh, we're not balanced yet. We have to get this scale balanced if this equal sign is going to be the truth. So I need to start monkeying around with these hearts here. I'm going to add a heart. Okay, still not balanced. Add a heart. Still not balanced. Add a heart. Okay, still not balanced. Let's add one more. Hey, check it out. Look at that. Right is balanced with left, or in other words, they equal each other. So now you're probably screaming at your computer, Lewis, 7 equals 7, duh. That's why it's balanced. Well, I mean, yeah, 7 is 7. 7 equals 7. You might be asking yourself, well, then what the heck are we doing here? Why are we playing around with the scale? 7 equals 7. We already knew that. Well, we can take a look at these different shapes here. We started with 3 of these little squares, or diamonds, whatever. 3 of these purple guys, because we knew we had 3. We had to add these hearts until we became balanced. And how many hearts do we have? Well, we have 1, 2, 3, 4. So that tells us what m must be equal to. We had to add another 4 to make the left side equal 7. And check this out. If I write it in underneath, 3 plus 4 equals 7. All right. Now I'm going to simplify the left-hand side because I don't like having operations. I want to simplify that. 3 plus 4 is 7, drops down. Equal sign drops down, and the other 7 drops down. And check it out. 7 equals 7, just like we knew. Okay. So here's a visual for you just to kind of keep in mind what the heck we're doing when we're working with these one-step equations and two-step equations. We have to keep in mind that the equal sign is kind of just like a balance scale. And we have to have right side balance or equal left-hand side. Okay. Now, do I expect you to pull out Mathagon and pull out a balance scale and do this every time? No, that is not efficient whatsoever. Your time is way more valuable than that. So what we're going to do is actually look how to do these mathematically. So what we have to remember is the word inverse. Inverse essentially means opposite, okay? So we have to ask ourselves, what is the opposite or the inverse of addition? Well, yeah, you guessed it, subtraction. The opposite of addition is subtraction, okay? Or more pointedly, we can say the inverse operation of addition is subtraction. All right, well, how about multiplication? What's the inverse there? Yeah, you bet. The inverse is division. Okay, and we can prove that right now. If I go, I'll scroll down here a little bit. If I go 3 times 2, that equals 6. And now I can work with the inverse and just go backwards. 6 divided by 2 equals 3. We're just working backwards using the opposite or the inverse operation. Let's do it with addition and subtraction. 10 plus, 3 equals 13. Now we'll work backwards. 13, the inverse operation to add addition is subtraction. Take away 3, and that equals 10. So inverse operations. You just work the other direction, and you use the inverse operation, and you arrive at the same term. Kind of cool. Now again, what the heck does this have to do with this up here? Well, when we're doing a one-step equation, we're trying to solve for the variable. The variable could equal anything. It could be 1, it could be 1,000,000, it could be 1/10, it could be anything. So I'm trying to figure out what m is. And my end goal is to have m all by itself equaling a number. And how the heck do we do that? Well, inverse operations. So it's 3 plus m. I just want m on its own, so I got to get rid of this 3. And this is positive 3, so what's the inverse of positive 3? Yep, subtract 3. Now, let's go back to our scale. What happens if I take away those 3? We're not balanced again. That's not good. We have to be balanced if this is going to be true, if that equal sign is going to be true. So if I take 3 away on the left side, yep, I better take away 3 on the right side. So I'll take away 3 on this side too. Okay, now check it out. We're balanced again. It's kind of nifty. So 3 take away 3 cancels off. M drops down. Equal sign drops down. 7 take away 3. Yep, you betcha. That's 4. And there's no more operations. This is simplified. I have my variable equaling my value. And I'm going to finish with circling my answer. M is equal to 4. And there's my visual proof right there. I've got 4 heart thingies there. Okay, let's do another example. Okay, so here's my next one-step equation here. N, which could be anything, subtract 2 equals 6. All right, well, I've already got my 6 dots on the right-hand side of the scale. Okay, and I'm subtracting 2. Well, again, remember that our goal is to get this variable all by itself equaling something. So then we know what the variable is actually equal to. So I have to use inverse operations. So n right now, it has subtract 2 tagging along. Let's get rid of that subtract 2. And what's the inverse of subtraction? Yep, addition. And we'll just add the same amount so we can cancel them off. Okay, but again, remember, if I add 2 to the left side of the equal sign, I must add 2 to the right-hand side, rather. Okay, so subtract 2 and add 2. Yep, that cancels off. N drops down. Equal sign drops down. 6 plus 2 equals 8. All right, so I added 2 to this side. I added 2 to that side. Okay, and I'll have to make sure the scale balances. And there you have it. 8 is 8. N is equal to 8. And I almost forgot to circle my answer. Cool. Okay. So again, the equal sign, think of it as a balanced scale. We have to get both sides balanced if the equal sign is going to be the truth. Cool. So now we're going to work on two-step equations. So next video that I put out, it'll be explaining that. Good luck with the one-step equations. Make sure you're using inverse operations. Make sure you're dropping your math down just like I am here, okay? You can even show that you're canceling off things. Good luck. Have fun. Actually, wait. What am I thinking? I almost forgot. We got to multiply and divide as well. I'm sorry, guys. Let's just do one 3p. And remember, whenever a number is touching a variable, the implied operation is multiplication. So 3p is equal to, I don't know, 15. Cool. So 3 times something gives you 15. Well, again, I want to get p all by its lonesome, equaling something. So how do I do that? Well, I use inverse operations. The inverse of multiplication, yep, you betcha, is division. And so instead of timesing by 3, I'm going to divide by 3. And I have to do it on the other side if that balance scale is going to stay balanced. So times by 3 and divide by 3 cancel. P drops down. 15 divided by 3, yep, you betcha. That's 5. P is equal to 5. Kind of cool. Let's do a division one real quick. Let's say I've got n divided by 11 equals 4. Okay, remember fractions, that's just a division question, right? N divided by 11, well, it's being divided by 11. What's the inverse of dividing by 11? Yep, you betcha. Timesing by 11. And if it's happening on the left-hand side, it must happen on the right-hand side. Divide by 11 and times by 11 cancel each other out. N drops down. Equal sign drops down. And 4 times 11 is 44. Pretty darn nifty. Just like that. All right, guys. Anyway, this one I actually am saying bye this time. Good luck. Have fun. See you in the next video.